Hi there, welcome to this tutorial on the applications of counting. My name is Adetunbi Emmanuel. In this tutorial we'll be looking at permutation and combinations. So what is permutation? By permutation we mean the number of ways of arranging n distinct objects. Talk about arrangement or we'll talk about permutation. While when we talk about combination, talk about selection. So let's look at certain examples for us to see the distinct difference between them. The number of permutation of letter A, B, C is what? Number of permutations of the letter A, B, C is what? Okay, I will say number of permutation, we talk about number of arrangement. Okay. And I said earlier that permutation has to do with arrangement. So in how many ways can you arrange ABC? Of course, ABC are 3 letters. So how many can we arrange 3 letters? Clearly, this is 3 factorial. So how many ways can you arrange n object? You say n factorial. So what do you mean by n factorial? N factorial equals n times n minus 1 times n minus 2 times 1. So this is n factorial. So the number of permutations of letter ABC is actually 3 factorial. And that is 3 times 3 minus 1, that's 2. 2 minus 1, that's what? 1. So that gives us 6. So there are 6 distinct ways of arranging ABC. Okay, let's try them. You can have A, B, C. You can have A, C, B. You can have B, A, C. You can have C, A, B. You can have C, B, A, B, C, A. Any other arrangement we can talk about will just be a repetition of any of these 6 distinct arrangements. So that is permutation. Okay, so the number of permutations of letters of possibility, Possibility. Permutation has to do with what? Arrangement. So we have n, which is number of letters, that is 11. Then we'll consider that's supposed to be 11 factorial. Number of arrangement 11 factorial. But because we have some numbers repeating, we have to account for the repetitions. So total numbers of arrangements we can have for the letters of this word possibility is 11 factorial all over. Okay, we have 2s, so we have the 2 divided by 2 factorial. I mean, which one repeats again? That is high. We have 3 highs. Do you have any other letter repeating again? That's all. So the number of arrangement we can have 11 letters in the word possibility is 11 factorial over 2 factorial 3 factorial. So you write 11 factorial divided by 2 factorial divided by 3 factorial. So if you use a calculator, you are going to have 3,326,400 distinct ways of arranging the letters in the word possibility. Okay, now let's get under permutation. The number of circular permutation of 6 persons sitting around a circular table. Now this has brought us to a very important aspect of permutation. When you're arranging items in a circle, if you're arranging n items, that will be n minus 1 factorial ways of arrangement. Okay, let's look at this again. If you're arranging n objects around a circle or in a circular form, there will be n minus 1 ways of arrangement. So if you have 6 persons sitting around a circular table, how many ways of arrangement do we have? That will be 6 minus 1 factorial, which is the same thing as what? 5 factorial. And 5 factorial is the same thing as 5 times 5 minus 1, 4, 4 minus 1, 3, 3 minus 1, 2, and 2 minus 1, 1. Once you get to 1, you stop. Multiply this very, very good, get 120 ways. So let's now look at how many number of arrangements can we have by the time we arrange R out of n items. Okay, if you have n items and you're taking them R at a time, so how many distinct arrangements can you have? So this is given by n permutation R. So n permutation R is defined as n factorial over n minus R factorial. So it's the arrangement of n items taking R at a time. So please, let's take note of that. So in how many ways can we sit 4 boys and 2 girls in a row? 2 girls are to sit next to each other. So basically it means we are arranging 4 boys and 2 girls must sit together. That's we have arranging 5 different objects, 5 different persons, and that will be 5 factorial. If the 2 girls must sit together, you have a 5 factorial. Because when you have 2 girls, is that one sits, when one is sitting on the right, we consider that as a configuration. By the time there's a shift of change, that's not configuration, so we can actually have 5 of them being arranged in 2 different ways. So that's 5 factorial then multiplied by 2 factorial, which equals 240 distinct ways. So this should be taken note when anytime you are looking at permutation, the number of ways of arranging people or items. This is very important. So if you want to arrange 10 distinct objects taking 2 at a time, 10 distinct objects taking 2 at a time, that is 10 permutation 2, and that is 10 factorial over 10 minus 2 factorial. This is numbers of ways of arranging 10 items taking 2 at a time. And 10 factorial, we have 10 factorial over 10 times 10 minus 1, 9 times what? 8 factorial all over 8 factorial. So this cancels out. 10 times 9 gives us 90 ways. So if you want to arrange 10 objects taking 2 at a time, we're going to arrange them in 90 different ways. So this is permutation for you. So let's look at now. Well, if you want to select k objects from n distinct objects, if you have n objects, I want to select k out of them. That is n combination k. So as I said earlier, the combination has to do with selection. So this is given by n factorial over n minus k factorial k factorial. Okay, so please k is just an arbitrary value. You could have used r, m combination r is as n factorial over m minus r factorial. Now if I look at this very carefully, this is something as n factorial over m minus k all factorial times 1 over k factorial. N factorial over n minus k factorial is the same as n permutation r, n permutation k, as we have here, over 1 over k factorial. This will be important. take note. So if you have your number of possible arrangements, if you divide that by the factorial of the number of objects you are selecting, it will give you the same value as the number of ways of selecting k object out of n distinct objects. So let's get examples. What's the number of ways of choosing a committee of 5 from 9 persons? What's the number of ways of choosing a committee of 5 from 9 persons? That's 9 combination 5. That gives us 9 factorial over 9 minus 5 factorial 5 factorial, which is 9 factorial over 4 factorial 5 factorial, which will give us 126. So basically, this is a fundamental principle of combination. Find the number of ways in which a committee of 4 can be chosen from 6 boys and 5 girls if, so this has to do with constraints, or say conditions, which we need to consider carefully. Find numbers of ways in which a committee of 4 can be chosen from 6 boys and 5 girls. So let's look at this. We have boys 6, we have girls 5, okay, making a total of 11. Okay, we want to choose 4. So said if it must contain 2 boys and 2 girls. So that means if it must contain 2 boys and 2 girls, it is clear we are picking 2 boys from 6, that is 6 combination 2, multiplied by we are picking 2 girls from 5, that is 5 combination 2. This is taken. So that gives us 150 different ways of making such selection. Now suppose we are given a different condition, and that is if it must contain at least 1 boy and 1 girl. Now this is where many students make the most error or most mistakes. At least 1 boy and 1 girl means you can have more than 1 boy. Yeah, so we can have, if we have 1 boy, for us to make a selection of 4, then we have to pick 3 girls. If we take 2 boys, it means we have to pick 2 girls. If we take 3 boys, we have to pick 1 girl. I can't pick 4 boys. Why? Because I must have at least 1 girl. So 1 boy, 3 girls gives us a combination of 6 combination 1 times 5 combination 3. Okay, this combination gives us 6 combination 2 times 5 combination 2, and this combination gives us 6 combination 3 times 5 combination 1. Hope this is well taken. So you have to write out the various configurations you can have, and with that, look at the combinations in question. Okay, so if we multiply this, 6 combination 1 gives us 6, 5 combination 3 gives us 10, 6 combination 2 gives us 15, 5 combination 2 gives us 10. So summation of everything here, this will give us 60, 150, then 100, and this gives us a total of 310 distinct ways. You sum it up. So 310, this is 310 ways of selecting. 310 ways of selecting. Please let's take note. When you're given constraints or conditions, you have to consider them very well. Okay. Now let me leave us with some questions for us to attempt. A board consists 12 men and 8 women, if a committee of 3 members is to be formed, in how many ways can the committee be formed in order to include 1, at least 1 woman, 2, more women than men, 3, a particular woman is included. Okay. Please, I'd like you to try your hands on this. This has brought us to the end of the tutorial. In this tutorial, we've looked at the principles of permutation and combination. Please, in the next tutorial, we'll be looking at other major aspects. We're looking at probability, at probability theory, very important. Then we'll go to probability distributions, and that is the main aim of this series. Thank you. Please do join me then. Okay.